In this lab, you will learn how to calibrate a pH meter to be able to test the pH of different solutions. When calibrating a pH meter, we used a two-point method so we could calculate accurate pH data. In this method, the electrode is calibrated using two different buffer solutions. A buffer is a solution that resists changes in pH when small amounts of acid or base are added to it. In our lab, we used a pH 7 buffer and a pH 4 buffer to calibrate our pH meter. Before using our pH meter, we rinsed it with distilled water and rinsed it after every use. When the pH meter was not in use, we properly stored it. Our pH is located on the bottom right-hand corner of the screen.
Rebecca Draper. We're about to calibrate the pH meter. So first, we're gonna rinse it with distilled water. And then we're going to insert it into our pH 4 buffer. After we get the pH calibrated for that, we rinse the meter again. Okay, so after we rinse off our meter, we're going to put it in our 7 buffer, 7 pH buffer. So now we're going to test the pH of our unknown orange juice. Calibrating a pH meter. First, you're going to rinse your pH meter with distilled water. And then we're going to insert it into pH buffer 4. Correctly in the video, just pH meter reads 4. Going to liquid distilled water. Different to it's not. That's something different. Whatever. And now that is rinsed, we're going to insert it in pH buffer of 7. Now that is reading correctly, that means that our pH meter is calibrated correctly and we'll be able to use it on other solutions to determine their pH.
Don't forget to store your pH meter when it's not in use.
Now that we have calibrated our pH meter, now we're going to be able to use it to determine the pH of other solutions. Here we have apple juice, so we're going to put our calibrated pH meter in it to determine the apple juice's pH.
And you can kind of smell it.
Wait, which is this?
That's HCl.
And we have to test those?
As you can see, apple juice is slightly acidic, so
testing of a buffer solution calibrated. Before we start, let's off the water, so we'll do that real quick. And then we put it in this solution, which is a pH of 4 test. Make sure it's calibrated. it's showing that the pH is 4, so that's working. That's good. Rinse it off one more time. Now we're going to test it in this solution, this buffer, which is having a pH of 7. And that buffer is showing to be 7, so that's good also. Rinse it off the last time. And put it back in. So now I'm going to test the pH of unknown acid, so I'm going to clean it off to begin. Put it in. Take it out, clean it off one more time. Now we're going to talk about the difference between the dissociation for a strong and a weak acid. And the difference is that for a strong acid it will dissociate completely, and for a weak acid it will only dissociate partially. And how that affects the equilibrium is that for a strong acid it will be more product favored, and for a weak acid it will be much more reactant favored.
Here is our final chart with the pHs of all of our solutions.